This is Vivek Kumar Anand, and today I'll be talking about the basics of cybersecurity, and then I'll be moving to the some practical of sniffing. So, as you know that the CIA triad is very much important in information security or part of the cybersecurity because this CIA, without this CIA, uh, data security we cannot imagine. Confidentiality, the CIA stand for the confidentiality, integrity, and availability. So this C confidentiality actually talks about that only authorized entities involved in the communication should have access to that data. Integrity ensures that only the authorized entity should have access to the data as well as even the access to modify the data. And availability ensures that only authorized entity can actually avail the services anytime. If the services are not available, then that would be considered as an attack on the availability. Same way, if in any way unauthorized entities are actually doing some attack on the confidentiality, that will be considered as an attack on the confidentiality, and that attack will be referred as a interception. So that's what even we will be talking about in the demonstration as well after this. And then integrity, attack on the integrity will be referred as a modification. And if any unauthorized party is doing any attack, or you can say the modifying the data, then that would be referred as a modification and as an attack on the integrity. So this is the CIA triad, and this CIA triad is very much important for the data because we cannot imagine the data without this CIA. It is just like basic needs of the data. So when we talk about the security, the CIA tried, this ball, what you can see in the red in center of this triangle, it should be in the center only. Why it is in center? Because things should be balanced. We cannot do that like this ball is moving to the integrity or confidentiality more and there is no availability. No, because for any business, it is very much required that this ball should be in center. That means CIA triad should be balanced. So when we are talking about the business operations, so we always talk about the business triad as well. That means business, cost of operation, and ease. So that means we cannot apply a lot of security because security always will increase the complexity also. Because like in the same way, you can understand one example that we cannot add more than one lock at our gate because every time you will have to lock and unlock your main gate each and every time, and that would be tedious process whenever you want to enter into your home or you want to actually lock your home. So it would be the tedious process. So definitely everyone wants the simplicity, and so you will have to manage that balance in the security also. Then we will move to the some demonstration. So after this, I'll move to the demonstration that I'll do with the Wireshark. So this demonstration is based on the sniffing. So what I'll be doing here, I'll be using this Wireshark. This Wireshark is a open source packet capturing software. When I'm saying open source, that means you can actually download it free from the website. So it is having one authentic website. You can download it, you can install it, and then you can use it. So there are various features of the Wireshark. That's what you can use it. You have various options like wherever you are having the data transmission. So it will be showing you the various adapter. Adapter is something from where your data is actually flowing in your laptop or in your device. Because I'm having multiple adapter in my laptop because I'm using VirtualBox as well, virtual machines. So this is why I'm having virtual adapter. Might be in your laptop or in your device. You are seeing a few adapters, not all. So that's perfectly okay. So I can select the adapter as Wi-Fi because right now I'm connected to the Wi-Fi. So I'll select this adapter as a Wi-Fi in my machine. So I'll just click on the start and it will ask me that you want to actually capture the packet or you want to save the captured packet before starting any capture. So I'll do it continue without saving. And then it will start capturing a lot of packets you can see. Okay, so now what I'm doing, I'm just doing the interception. Wireshark is actually capturing the packet, and lot of packets have been captured in this Wireshark. So this is the beauty of the Wireshark, that you can actually capture the packet. You can see the content of the packet. Maybe some packets are encrypted, but still you can see a lot of information in this packet. Okay, so I'll stop this capturing packet, and then I will uh, explain what these packets are doing, and what are the various contents of the packet. So what I'll do, I can actually apply a lot of filters here. First, you can see that if I want to actually apply all the TCP packets only, just I can type the TCP as well. So once I will put the TCP, I can see only TCP packets. So let me show you one TCP packets. So this is something you can see here: frame, Ethernet, Internet Protocol version 6, and Transmission Control Protocol. So as you know that OSI is a reference model. That's what we have studied. All of us have studied. So OSI is the one reference model, and TCP/IP is the practical model. That's what we are using. So all these packets, and you can say data, is a part of the TCP/IP, because this frame is a part of the data link layer. So you can see the content of the data link layer. So whatever the responsibilities of the data link layer, you will find all the contents here. Then this Ethernet, you can see the destination address and all. So this is a part of the physical layer again. Internet Protocol version 6, this is a part of the network layer. So because here IPv6 have been implemented, so you can see the source IPv6, destination IPv6, and this is the version and all the details, flow label. So if you will see the header of the IPv6, you will find all the contents here. And then you will see the transmission control protocol. Transmission control protocol is a part of the transport layer, because transport layer is very much important in TCP/IP model, or I can say the OSI model, because it is mainly responsible for providing reliability. Even the three-way handshaking is happening in this. I'll show you how three-way handshaking is happening. So you can see this source port number, because port numbers are associated with the services. So this 443 is associated with the HTTPS, and destination port number is 58758. That means uh, packet is, or you can say the data is actually leaving from this HTTP connection to this destination port from this system. And then if you will see the I can say the complete packet, then you will see this is the main data. You can compare it with the even TCP header also, and you will find all the details matched with that. And then I'll talk about the main content of the three-way handshaking. So what is a three-way handshaking? Three-way handshaking is happening between source and the destination. What is the purpose of three-way handshaking? The purpose of three-way handshaking is to be ensure that once data connection have been established, then only data transfer phase will start. Because TCP is very well known for the providing reliability. So if reliability won't be there, there is no meaning of the data transmission then, because TCP is ensuring that data should be reliably transferred to the destination, and if there is any problem, so retransmission can happen. So TCP is actually achieving that. So how it is happening, the three-way handshaking? Because TCP contain actually many flags. So if I can show you here, you can see this is a flag. So here in the TCP, you can see this one bit is set to the acknowledgement set. So this means ACK flag is set to 1, rest of the flags are set to 0 here. So this means this packet is mainly acknowledgement packet only, that is going to the destination. From source to destination, acknowledgement is going on from this packet. So this is what we can understand. So these flags are actually very much important. So if in TCP packet syn flag, that means synchronization. So this is what you can see, syn flag. So if this syn flag is set to 1, so if I can select it and highlight it for you, so you can better understand it. So you can see this is a syn flag, and if this syn flag is set to 1, and I'm transmitting the data from source to destination. Okay, so this is a source, this is a destination. If I'm writing here roughly here, so this is source, this is what I'm referring, destination here. Okay, so what is happening? One transmission is happening from source to destination, and syn flag is going on. So syn flag is like hello. So when we call someone, we always say hello, and then from other side also someone is saying hello, how are you? So that is like syn. That means someone is actually saying hello to us, and as well as someone is asking, how are you? So that is acknowledgement is also coming from the destination side. So first packet is SYN. So this is one flag, and then from destination to source, SYN plus ACK. So that means synchronization plus ACK will be transferred to the source also, and then source will again transfer the ACK packet to the destination. So this is what we are calling three-way handshaking, SYN, SYNAC, ACK. Okay, so this is the three-way handshaking, and it is happening like that. And once the data establishment, you can say that. Okay, so once connection had been established, then only data transfer will start. Okay, and then data termination will happen. Even data termination is also happening in the four-way with the four-way handshaking. Okay, so that is having the different mechanism. So this is what we are actually doing and we are achieving out of it. And this Wireshark can help us to understand the data communication in better way. Now I will take you through the various filters also, that you can actually filter the various packets, because maybe you have captured thousands of packets in this Wireshark, then it won't be very easy to detect each and every packet, to look for some data in each and every packet. So what you can do, you can always apply the filter like IP.IDDR, that means address, equals to you can have any ID. For example, if I'm putting 192.168.1.38. So this is what I'm putting, and you can see this. Uh, so the packets have been now filtered. Okay, so either you can see this IP as a source or as a destination. Okay, so this has been filtered now. So each and every packet is now having this IP at least either in the source or in destination. Now, if you want to have only that, I can say that TCP, okay, I can apply more flags as well, like TCP dot flags, and I can select the SYN flag as well. So TCP dot flags dot SYN equals to 1. Okay, dot SYN, and I can see this. So this is what you can see this. So the SYN and ACK, because ACK maybe some packets are having even SYNAC as well. So this is how I can actually filter all the packets. Now I can show you the TLS communications as well, because TLS is something transport layer security. Transport layer security is important part of the data connection. You can say that how the connection is going to establish. So if I can apply the TLS filter, I'm sorry, TLS. Okay, so if I'm saying TLS, so you can see this application data, but I'm not interested in the application data as of now, because I want to show you the various other things, like how connection is being established in this part. So what I will do, I will again capture the data, and I will open any website which is having TLS communication. So I will just start the google.com, and Wireshark have captured the data. I will just stop it now. Okay, so now I will show you this client hello and client server. So these are the few packets what you can see here. It is actually, you can see here, it is google.com only. That's what I have just opened, and this google.com packet have been captured. And once I will show you this client hello. So this client hello transport layer security protocol, you should see here. This is belonging to the google.com, so you can be sure that yes, this is the same packet what we have opened in the browser. So here one important term is that handshake protocol. Handshake protocol is something that means my system or my browser is trying to establish one connection with the google.com server with the TLS connection, because TLS is providing the security above on the transport layer. And then you can see this handshake protocol is being implemented, because TLS is having three protocol in it. Handshake protocol, alert protocol, and record protocol. So handshake protocol is mainly responsible for doing the handshaking and establishing the connection. And then this client hello is happening. So this is a version of the TLS 1.2. And then the most important thing is these cipher suites. So this is the length of the cipher suites. This is 34, and the total number of cipher suites are 17 cipher suites. So these are the 17 cipher suites offered by my system or my browser to the server, and then server will be choosing any one, and based on that they will be having all the encryption and all the encryptions, and the connection will be established based on this cipher suites only. So this is like something you can understand that if we are going to someone, or if we are visiting someone's home, then someone is offering us some tea and some snacks. So this is like some tea and snacks, and then the server will be choosing anyone. Okay, not all. So these are the like content of the TLS packets. Same way I can show you the server hello as well. So in the server hello, you can see this handshake protocol again here, and then here cipher suites you can see this. So this is the cipher suites. This is what one cipher suites has been chosen by this server, okay, google.com server only, and then this is the session id. So that means connection have been established, they have negotiated for the cipher suites, they have established the connection with this session id, and now they can have the secure communication between client and server. So this is how the secure communication is happening between client and server, and this is how even the sniffing can be done. So all these things even can be done with the burp suite as well. So you can actually intercept the data with the various tools, because the same thing can be done by the number of tools. But this is something like you can have a simple interception as well, and you can have a detailed look of the packets as well. So this is a brief, you can say, description and introduction about the sniffing and the packet content about the TLS, and then how you can sniff the packets and all. Yeah, thank you.